Guys, welcome to the next lesson on empirical and molecular formula. In this lesson, we're going to be looking at what empirical formula is and how to calculate it, as well as a molecular formula. So empirical formula is a method or way of displaying the simplest whole ratio of those elements in a particular compound. So we have three different empirical formulas here, and they are water, ethene, and calcium carbonate. This is the simplest way in which the elements can combine. So there's, for every 2 hydrogen atoms, there is 1 oxygen atom in water. And for every ethene molecule, there's 1 carbon atom and 2 hydrogen atoms. It's the simplest way of those particular elements forming together. That is the empirical formula. So to determine the empirical formula, we look at the mass of each element in a particular compound, and then we use the moles to work out the ratio of the particular elements. So we begin with obtaining the mass, then we calculate the amount of mole, using typically mass over molar mass, and we convert the number of mole of each element in the previous step to a whole number ratio, and then we work out the empirical formula. And we'll do an example of that now. But this is the flowchart that we'll be using today. Let's look at this. We have a compound of carbon and oxygen, and it contains 27.3% carbon and 72% oxygen by mass. So percentage composition is given to us here. It asks us to calculate the empirical formula of that compound. So we know that we have 27 grams, or 27.3 grams of carbon, and we have 72.7 grams of oxygen. That's because it's written as a percentage, so it's therefore out of 100, so therefore we would have 72.7 grams, which is the same as 72.7%. From there, as the flowchart says, you've got the mass of each element, you then calculate the amount in mole. So to calculate the mole of carbon, we simply divide it by the molar mass, which is 2.28 mole, and we find the molar mass of oxygen, which is 16, and we use that to divide our mass, giving us 4.45 mole of oxygen. From there, we want to find the simplest whole ratio, the key here, the simplest whole ratio of those two elements. So we divide the numbers by the smallest number of moles calculated in the previous step. So here we had 2.28 moles calculated, and we had 4.45 moles there. Next step then is to divide 2.28 by itself, the smallest number I've calculated, and we also divide 4.54 by 2.28. That gives us a ratio of elements. We have a 1 to 2 ratio, which means that carbon and oxygen, we'd have carbon dioxide written as CO2. 1 molecule of carbon here, and we'd have 2 molecules of oxygen. So there's our oxygen, and there's our carbon. Molecular formula. A molecular formula is the correct ratio of elements, or is it displaying the exact ratio of elements in that particular compound, and not just the simplest ratio. So here's our empirical formula, H2O. It's the simplest way of writing it, which is also the same as the molecular formula in this case. However, ethane may be written as CH3. That's the simplest way of writing it. The correct way of writing it, or the correct chemical structure, is actually C2H6. Same again for glucose. The simplest way of writing it is CH2O, but it's actually this number of elements in there. So there's a purpose for the molecular formula. So to determine the molecular formula, it's a similar step as what we've done with the empirical formula. And to do that, first of all, you need to calculate the empirical formula. Then you work out the molar mass of the empirical formula and the compound. And then you determine the number of empirical formula units in the compound, and then you write the molecular formula. So let's have a go at this with an example. The compound here has got the empirical formula CH, and the molar mass of the compound is 78 grams per mole. What's the molecular formula? So the molar mass of the particular CH unit, or the empirical formula that we're given, is going to be relative atomic mass of carbon, which is 12, and the relative atomic mass of hydrogen, which is 1. So we've got 13 grams per mole is our molar mass there. Now, what we're going to have now is we've determined the molar mass of the empirical formula of the compound. That's here. We've determined the molar mass of the empirical formula and of the compound. We've done that now. So now we have to work out the number of empirical formula units, this step here, in the compound. So we divide the molar mass here by the molar mass units of that particular empirical formula. So 78 divided by 13, which gives us 6. And now we multiply the empirical formula given to us at the beginning by that particular empirical formula units in the compound. So C6H6, or there is a 1 below each of those, and we're multiplying that to C1 times 6, H1, 6, which will then give you C6, H6. This is the summary of today's lesson. The empirical formula is the simplest whole ratio in which two or more elements combine, and the molecular formula is the actual ratio in which the two or more elements in a compound combine or exist. This is what you need to know by today. You need to be able to distinguish between what an empirical formula is and what a molecular formula is, and be able to calculate empirical and molecular formula when given the appropriate information. These are the questions for today's lesson. Thanks for watching.